Hi all, this is Junaid here from Edureka and I welcome you all to this interesting session where we'll be seeing how to detect COVID using chest X-ray. So without any further ado, let me quickly walk you through today's agenda. We'll start this session by understanding the fundamental concepts of the algorithm that we'll be using today, that is convolution neural network. Moving ahead, we shall see how images are being processed using CNN or convolution neural network. And finally, we'll end this session by implementing CNN algorithm for detecting COVID in patients' X-ray. Before we begin, do consider subscribing to our YouTube channel and hit the bell icon to stay updated on trending technologies. And also, if you're interested in online training certification, please check out the link given in the description box below. So why CNN, right? Well, before we come on to answer that, let's understand what are the basic components that go in here. CNN is actually an advanced version of artificial neural network. Now you might be wondering, what is artificial neural network, right? Well, an artificial neural network is a piece of computing system which is designed to simulate way humans analyze and process information. It is a foundation of artificial intelligence and solve problems that would prove impossible or difficult by human standards. ANNs have self-learning capabilities that enable them to produce better results as more data becomes available to them. You see, what I'm trying to say here is ANN has something called as neurons, and each of these neurons are interconnected to each other with a link. And let me tell you, each of these neurons are capable of producing their own decisions. All right. And the way this model tries to correct whatever the classification is done is by back propagation. So now that we know what is ANN, let's see whether we can use ANN for images. Well, if you are trying to ask me, can I use ANN for images? Well, the answer for this is simply yes. Artificial neural networks can definitely be used for images. Here, the way this works is whatever the image is there will be converted in the form of a matrix. And we all know this matrix is nothing but a pixel values. And when these pixel values are passed through artificial neural network, it tries to analyze it and gives out kind of good results. Now you might be wondering, if ANN is capable of image processing, then why do we have convolution neural network? Well, you see, images are more than just pixel values, all right? So images have features and patterns. So what I'm trying to say here is that artificial neural network fails to capture the pattern. So let me tell you, like, for example, if as you can see an image of cat over here, artificial neural network over here knows that this pixel value over here is black. Okay, but it cannot see the pattern that is over here. All right. And this is exactly why we use CNN. CNN or convolution neural network is more or less about detecting how patterns are. Okay. And one of the reason why we have to use CNN over ANN is because of three major reasons. Okay. First off, we have something called as curse of dimensionality. As we have huge number of points in an image, it becomes evitable over here. So as you can see here, as this is an image, pixel image, let me show you with the help of a pen. As this is the image and it has so and so number of channels over here, and when I flatten this image, you can see here we having huge amount of data points. Okay, and this is something referred to as curse of dimensionality. So this is one reason. The second reason why we should use CNN is because of image variance. As I mentioned earlier, when we use ANN, it's all about flattening the image and it tries to read a image pixel by pixel. Okay, and now when this happens, you will see that when we compare it with respect to these two images, we do have a cat image over here. As this cat image is not present in this pixel value, ANN will come to a conclusion that this image does not have any cat. So this is exactly why we use CNN. CNN makes use of features. Okay, so it will have this slider which will go through each and every pixel value or a bunch of pixel value, and it will say, okay, it will learn this particular pattern. All right. So what happens over here is, as this pattern is present in this part of the image, now whenever this slider encounters a pattern on this input image, it will get to know that this particular object is present or not. The next reason to use CNN is the curse of dimensionality. Next reason to use CNN is because of overfitting problem. As you can see here, we have huge amount of data set, right? And what this will do is our neural network will by heart each and every of these particular data points. Okay, and now when I fit a new image, what happens is it will fail to recognize it. And the reason for this is because our model is kind of fixated on learning only the similar kind of problems. Okay, so there are three major reasons. Let me quickly give you a recap. First one is the curse of dimensionality, then we have image variance, and finally overfitting issues. So now that we know why we should use CNN, let us now quickly discuss what exactly is convolution neural network. Well, convolution neural network is a deep learning algorithm which takes in images as input and assigns importance to various aspects or objects in the image. and it is able to create a differentiation between one image or one aspect from the other. The pre-processing required in convolution neural network is much lower as compared to other classification algorithms. The architecture of convolution neural network is similar to that connectivity pattern in the neurons of a human brain, and this was inspired by visual cortex of a human being. Here, individual neurons respond to the stimuli only. So what I'm trying to say here is the neuron respond only if that specific feature is present. So this is what exactly is convolution neural network. So as you can see here, we have images that is an input, okay, and then we pass it through various filters. And each of these filters is responsible for taking one or the other feature. And now once these features are formed, we can reduce the size by using some meshes. And then we perform the similar task again and again. Once we sample the image to a certain level, we flatten these images. Or I can say we flatten up these layers and then we pass an artificial neural network over it. So let me come down here and show you how exactly this works. So as you can see here, we have an image of a spacecraft. Okay. And then there would be a slider which goes through all the pixel values. And if you say slider is of 3 cross 3, then it takes 3 cross 3 pixels at a time and goes through every pixel over here, or the grid of pixels over here. And then we pass out a convolution and a ReLU, which is an activation function. The reason why we do this multiple number of times is because we want to increase the non-linearity. And basically over here, we are trying to extract different features of an aeroplane. All right. And once we have enough number of features, what we do is we flatten these features into a single strip of images. All right. And then we pass them through a fully connected layer, and out of which then we can classify whether an image is aeroplane or not. And depending upon the type of classification, we can use the activation function. If the type of classification is binary, we can use something called a sigmoid. And if it's a multi-class classification, we can use softmax. All right, now, so let us move ahead and see what are the basic components that go in when we are processing images using CNN. First off, we have something called as convolution layer. And what this convolution layer does is that it is basically a set of filters. And these filters, when passed through our image or our image data set, it is capable of extracting specific set of characteristics. Now, for example, if I say here, I have an image, and this image has a cat. Okay, so obviously cat will have a pointy nose. Okay, and let's say it has a pointy ears and nose, right? So now when we have this convolution layer here, this basically here is an image. Okay, and now this filters, right? We can have not one, we can have n number of filters. And the filter size is usually 3 cross 3. And each of this filter is responsible for extracting one specific feature from the cat. Now let's say if this filter over here is responsible for detecting the cat's ears. So this is what this filter does. And the next filter might be responsible for detecting, you can say something like the nose of a cat. And the third filter might be responsible for detecting the shape, like overall outer shape, you can say. So this is what this filter does. This is practically what we do in convolution layer. And the way this works is that, we have this image. Let's say if it's a 3 cross 3 image, it goes through this 3 pixels at a time, and then it slides over to the next 3 pixels, and then finally it slides over to the next 3 pixels. And then when it goes through all the pixels, it then comes down to the next bottom line over here. It goes something like this. And this functionalities continues throughout the picture. And then it comes out with the features that is being extracted. And the number of filters that we use, like if I say there are 3, then the dimensions of our image also increases by 3. So it becomes whatever the size of the feature, comma 3. Okay. Usually the number of filters that we add totally depend upon which layer we are in. Okay. So we'll quickly get back to what I'm trying to say later on in this video. All right. So the next thing that we are going to use over here is going to be padding layer. So usually what happens is when we pass a convolution layer, the image size usually decreases by 2 pixels. The reason for this is because we are passing this particular image in that particular manner. Okay, we are passing this convolution filter. Now sometimes we don't want to lose a feature. Okay, sometimes a feature might be present at the corner, right? So what should I do if that's the scenario? Well, that's when we have padding layer. Padding layer is basically adding a pixel whose value can be 0 or 1 across this particular image. And now what happens is the image after passing the size of the image after passing it through a convolution filter would remain the same. All right. So this is what is called as padding layer, or adding paddings to our images. Next, we have something called as max pool layer. In max pool layer, we won't be learning anything new. It's basically used to reduce the dimensionalities over here. And the way max pool layer works is that, we can pass out a 3x3 grid or filter. And what this would do is this would just take in the maximum value in that particular grid. So if you can see over here, there's this filter, right? Max filter. And this goes through 3x3 grid over here. And whichever is the maximum value in this 3x3, that particular value is given out. And if you are asking me why am I using maximum value over here, the reason is because if I say in this particular matrix, right, let's say 7387, over here 8 is a maximum value. So this means that 8 is contributing maximum or the highest to that particular image or that particular feature in that image. So that's why I'm taking out the maximum number in this matrix grid. All right. So this is what exactly is max pool layer, and this is what it does. So now that we know what is convolution neural network, let me now quickly move to my code editor and show you how we can use CNN for detecting COVID in our X-rays. Alright, so as you can see here, the code editor that I'm going to use today is Google Colab. Alright, so now I have my data set which is available here, which I've already loaded. So I'll have this training data set, which has both COVID and normal. And then I'll also have this validation data set for both COVID and normal. So let me quickly show you one or two images over here. So this is images for COVID. So as you can see here, you can see the X-ray is kind of foggy and we have a couple of patches over here. And now if I have to show you the normal image, okay, so this is the normal image of an X-ray. So as you can see here, we obviously don't have much detailed information, or we personally can't analyze any features over here. That's because we obviously aren't radiologists or doctors. So what we're going to do here is we'll be feeding this label data to our deep learning algorithm, and then we'll see whether our algorithm works fine or not. Okay, so let me quickly zoom in over here. All right, so now what I'm going to do is I'm going to import a couple of libraries that we need. All right, so I have import numpy as np. Then we obviously need some matplotlib. Import matplotlib as pyplot. Let's import some deep learning layers. So from keras dot layers, import dense layer. Then we need convolution layer, so it would be convolution 2D. And then we have max pool layer. All right, and then we obviously need dropout so that we can prevent overfitting. And then finally we have to pass our whatever the outputs of the CNN we have to pass it through our ANN, right? So for that we have to flatten our layer. So that's why we are going to use flatten. Then we have from models, that is keras.models. Import here we can go with one of two ways. We can use either functional API or sequential model. So I'll be using sequential. And then I'll also import from keras because we have to load our images, right? So I don't want to use OpenCV. I can just use the image library which is present over here. So keras.preprocessing, import images. And let me just import keras. Let me just do that over here. All right, so this looks great. Let me execute this. Fine. All right, so what we are going to do is let us quickly jump and import our data set here. So the way I'm going to use the data set is by making use of data generators. Okay. And the reason why I'm going to use data generators is because with data generators, I can do some image augmentations. So what this image augmentation does is, we can change the characteristics in the sense we can tilt the image a bit, and we can also change it horizontally and vertically. With this, what will happen is we can have multiple dimensions for our algorithm to learn. Okay. So what I'm going to do is I'm going to create train data generator is equal to image. This is present in an image module dot image data generator. All right. And now what I'm going to do is, we all know that images, whatever the pixel values are there, it goes from 0 to 125. So I'll scale it down. Okay. So rescale, and every pixel would be rescaled by 255. All right. And then we'll also do some augmentation, that is horizontal flip. We'll give the value here as true. Okay. Then we'll also do some zooming. So zoom underscore range. So here will be 0.2. And next we have shear range. So sh EAR underscore range, and we'll also give it as 0.2. So let me quickly zoom out so that you can see a bit. Okay, yeah. So this is our training data gen. So let me execute this. Yeah. And now what I'm gonna do is I'm gonna like literally call our data set here. So let's say train data. Okay, so this thing will give us, this is basically a class. This class has a method called as flow from directory. So we can like directly import this. So we'll have to give the path of a directory. So our directory for our training data set is here. So let me copy this path and present it over here. And now we have to set the target size of the image. So let's say target size. By default, it will be 255 or something. So, but I'll be giving it as 244. Yeah. So by default, it's 256, right? So, okay, let's give it as 256. So 256, comma 256. There's along X and Y axis. And then we can also give a batch size. So batch size is going to be 16. And as we are trying to perform binary classification, we have to change class mode. This should become binary. And if by any chance, if this was like multiple, then it would have been multiple class, right? So no, right now it's binary. So binary looks great. And let me execute this. So as you can see here, it found four images which belongs to two classes. Now, if you want to see which are these two classes, what I can do here is train data. This has a built-in function which would give us that. So what I'm going to do is train data dot class indices. So let me execute this. So as you can see here, based on the folder names, it has discovered what are the classes. So COVID class is represented as 0 and the images that are normal is 1. Okay. And now similarly, we should do it for test data, but we can do that later. Okay, we will do it right away because we obviously will be needing that for our validation. Everything remains same here. So let me copy this and let me paste it here. There are just few changes. You see, first off, what I'm going to do is when it comes for testing data set, I don't want to give any augmentation over here. I'll just rescale the image. That's it. So let me give here as test, right? EST. And now this is going to be our test data or validation data. So now I'm going to pass here test data gen, then flow from directory. We just have to change the directory name. It's going to be val. So let me copy this, copy path. Okay, so let me remove this and replace it by the updated one. Fine. And then we have the batch size and even the class mode. So let me execute this. So it just found 60 images and that 60 images belongs to class 2. So let me just zoom out a bit so that you can see here. So as you can see, all I did was first off, I have like imported a couple of libraries. Let me give some comment here so that you understand better. Okay, so these are the imports and then load the data. Okay, so the data over here is the images, and now finally we'll build our deep neural model. Okay, so it will be CNN model. So now what I'm going to do over here to build a CNN model, first off we'll have to initialize a sequential. So I'll say model is equal to sequential. All right, so now what I'm going to do is I'm going to add a couple of layers. So first off we have to add convolution layer. So model dot add, and then over here we'll say con2d. All right, and here we have number of filters. If you remember, as I mentioned earlier, number of filters represents the features that you would extract. And usually when you are in the starting, right, you will be using less number of filters. This is because this usually takes lower level features, and lower level features aren't that important as because we won't be getting much information from lower level features. Then we have kernel size, that is the size of a filter. Usually it's 3 cross 3, and the reason it's 3 cross 3 is because it has become an industry standard after the AlexNet, right? And then we obviously have to involve non-linearity, so I'll be using ReLU. And finally, you need input shape. And the input shape, usually it has to be same as what we are using here. So it's going to be 256, 256, 3. 3 is because it's an RGB image, so it's going to be 3 channel, right? Now we are done with the first convolution layer. So now similarly, I'm going to add a couple more. So let me just copy this because it's just the same. So let me copy and paste it over here. And this is something which you're supposed to do only for the first time. Okay, and I can remove this. And next we will increase the number of filters by 64. After this, I'll be adding a max pool layer. So model, basically to reduce the dimensions. So model dot max pool 2D. You by default the pool size is 2 cross 2, so we don't have to worry about it. And finally we'll drop some layers. So model dot drop, model dot add, and we'll do some drop here. So drop out, and we have to give some rate. So this would be like 0.25. That's 25%. So similarly, we are gonna add like 5 convolution layers. So all I'm gonna do is copy this and just change the number of filters. Okay, now we have 64, 64, and then I'll change it to 128. That is the double of this. And now that we are done with this, what I'm gonna do is I'm gonna flatten this particular layer. So we'll have model dot flatten. Sorry, it's gonna be model dot add and flatten layer. Okay, so now our images would get flattened, and now we'll just pass our dense layer. So model dot add. So if you know what is this dense, if you remember right, dense layer is nothing but artificial neural network or multi-layer perceptrons. So here we are going to pass units. So it's not going to be a dropout, it's going to be dense. Let me zoom in a bit. And here we'll have to give the number of units. So the number of units is going to be like 64. And the activation, it's going to be ReLU. Looks great. And now we'll do some dropout. So model dot add, then we can just drop out. And here we'll just increase the rate here by 50%, right? So rate 50%. Because if I don't drop this out, our model will end up overfitting, and this would lead us to a loss. And now coming down to final output, so it will be model dot add. Then we'll obviously have a dense layer, but here the number of units is going to be 1. And here's a small quiz or activity for you. I would like you to comment why am I using number of units over here to be 1. All right. And now I have activation. Finally, for this I'm going to add a sigmoid. All right, looks great. And now once this is done, we have created a model. So we'll compile it, model.compile. Okay. And now we'll have to pass a loss. Type of loss that we're going to use here, we're going to use binary cross entropy. Either you can just type here binary cross entropy, or you can just use keras dot losses, and now you can get your binary cross entropy. All right. And now optimizer, you can use any optimizer you want. As of now, the good one is Adam. And finally we have metrics. So I want accuracy, and let me quickly execute this and zoom out a bit. Okay, here I have done a small mistake. It's not open, it's just gonna be optimizer. And let's execute this again. All right, so as you can see, I have made a small typo that was P was missing out. And let me execute this again. Great. Now let's see how our model looks like. So for this, I'll just be typing model.summary. All right, so as you can see here in the first layer, we have 896 parameters. Okay. And yeah, as we are passing through the first one, so we have 254. The size of the image is reduced here, as you can see. And as we go down, the number of parameters are increasing. And if you can see here, max pool 2D and dropout, we are not learning any new parameters. All right. And when I finally flatten this, we have this many number of parameters, that is almost around 73 lakhs, right? So yeah, we have 73 lakh parameters, which is fine. And now we are going to finally train our model. So to train our model, what I'm going to do is we'll just say model dot fit generator. All right. And now we are going to pass a generator. So that is nothing but train data, right? And then we have steps per epochs. So we'll say here as 8. All right. The number of epochs, I want it to be 10. And validation steps, so this will be 2. And finally coming down to validation data. Validation data over here will be test data. Let's see what I've named over here. It's test data. So let me quickly copy this and let's go down. All right, looks great. And let us now quickly execute this. This will take some time, so let's quickly wait for a while. All right, so as you can see here, our training is successfully completed and our model has performed quite good. All right, so as you can see here, our accuracy has obviously increased and our validation accuracy at one point has become 100%. I can say that it has overfitted some of this model, and we can actually enhance our learning by by having hyperparameter tuning, and we can also do some early stopping techniques. So with that way, we can get an optimal accuracy on our validation data. All right, so now what I'm going to do is I'll quickly get some random images. So I have some images which are present here on our COVID as well as normal data. So let me quickly find that up here. All right, so let me get my data from here. All right, so now that this is done, now I have this new folder here which says dataset. What I'm going to do here is I'm going to take some random input. So first off, let's have a path variable. This path variable usually takes in an image. Okay, and now I will create an image here, and I'll just do image dot load image. All right, and I'll pass the path and the target size. Okay, make sure you give a correct target size, because if you give a wrong one, our image, this model wouldn't work on it. So it's gonna be 256, right? So let me quickly give that up, 256 comma 256. So this would load our image, and now we obviously have to scale our image down. So it'll be img, this would be equal to image dot image to array, because we obviously have to convert that into a form of number. So img, and then I'll scale it down by 255. Sounds great. And now obviously I have to convert this into an 1D array again. So it should be like 1 comma 256 comma 256 comma 3, because if you see the model here, this none here represents the size, right? So as we are just passing one image, so it should be 1. So for that, it'll be image is equal to np.array, and then we'll pass out an image, and we'll also see the shape. And let's take from our data set, we'll take some, okay, I know that these are COVID images, so let's take some random image. I think there are around 3000 images which are present here. So out of this COVID, let me just randomly stop here, copy path, and let me paste it here. Okay, and let me load this. Yeah, so for this I have to pass it this way. All right, so as you can see here, now we have this, and now we'll predict. Okay, so we'll do model dot predict class. Okay, and now I'm just gonna give image. So we know that this is a COVID image, and now our model should predict whether the image is COVID or not. So it's giving me this class 0. So let's see what does class 0 represents here. As you can see here, class 0 represents image is COVID, and let's take another image here like randomly. So any random image. So I'll just stop down here and copy the path. And okay, I just have to change the number here. So let's say 1485. Okay, and let's see. Yes, again it's giving us 0, right? That means our model is working fantastic. And now let's take a normal image here. All of these images are nothing but the COVID X-rays. So let me close this and let me take a normal image. Okay, now the class it should give me is 1, right? If I pass a normal image. So let me just randomly choose some image. So copy path, change this to normal, and execute this and execute this. So it's giving me class 1. So it's working pretty great. Like if I give some more changes like 131, okay, some random image, and yet again it is giving me 1. So our model is working perfectly fine. And if I pass out any of the images, it's working totally great. All right, so this is about detecting COVID using X-rays. All right, guys, with this, we come to the end of our session. I hope you enjoyed and learned something new. If you have any further queries, please do mention them in a comment box below. Until next time, goodbye and take care.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!